Hello everyone and welcome back. My name is Corey and you're my rubber ducks for the evening. And this is the series of episodes where we are creating Tang, a custom programming language, a template scripting language, from scratch using C++. Vim is our text editor. We're doing this in a terminal window. We're using Flex, Bison, Google Test, and ICU. And yeah, just our wits. And I've been saying this from the beginning. I have nothing up my sleeves. I have nothing pre-prepared. This is 100% live coding, which means you see all of my mistakes and everything. And if on the right-hand side, I'm just going to go ahead and clean up everything and say make test watch, and it's going to start compiling, and we're going to see the tragedy that befell us at the end of the previous episode. Speaking of which, if I say git log, we can see that the last commit was for the end of episode 79. That's right, this is episode 80. But 79, where we wrote our first little command line utility, and part of what we needed to do for that was we adjusted Tang so that it could read from an input stream. The problem is I didn't do one of the fundamental things that needed to be done. I didn't run my unit tests. And so as we're about to see behind me here, the unit tests are about to fail. And our first order of business is to get those working. And then we're going to continue with our code. But anyway, okay, so let's see, get status. So no changes have been made. And now we see that 16 out of 59 tests passed. Only 16 out of them. Yeah, that's not good. So let's we're gonna open test.cpp, and I have a feeling that the problem is going to be in source program or source. I doubt it would be Tang base, but it might be. And I haven't looked into this yet, so we're going to see. You know, we're going to scroll up to the top. I want to see the very first one that fails. There we go. And it is line 82. So until then, we've got compile script, compile script, compile script. And if I go now to line 82, This one okay, so where I'm stopping is I didn't expect to see this error. Unexpected identifier, expecting end of code. Whereas what I have written here is unexpected malformed string. Let's come back to that. And then we've got these here. So, or is it the fact that they're failing? And then we've got more compile scripts. So we had some compile scripts that were passing. Well, 112 is the... Interesting. Okay, so I'm going to go to 2 here and just see what doesn't look right. So we've got program. When we're calling it with a string, we are populating this string, and we should probably have iStream code as a null pointer. Question is that going to compile first? It looks like so. Let's do the same thing here. I just want to provide a default. And I'm getting a segmentation fault. Anytime we get a segmentation fault, I'm always going to run a recompile first. If we still get it, then that means we probably have a pointer issue. And since we are right here, we're getting it when I added that iStreamCode null pointer. Oh wait, is that an optional? Yeah, it is. Okay. So it should probably not be null pointer, but is it null? I don't remember, but we're going to look it up. C++ optional. Just add the word reference. Hopefully it will give me a reference. And so is it just null opt? Yeah. Null opt. All right, let's redo this. Okay, no longer failing. I do like the fact that we're actually specifying that, so okay. And now with parse, we say the scanner is a unique pointer if all of this seems correct. The only thing I can think of is the code type getting through? Yeah, I'm not leaving that out. Well, there weren't my ideas. I was thinking that it was probably going to be something wrong with this section. See, and the only reason I'm doing this, I want to make sure that it's getting in there. Yeah, you see, that's the code. This is the code. So now if we go to the tests, I'm going to go down to the very bottom and p1 dot or p1 dot get result, and just see if this gives me an error of any sort. Syntax error, unexpected identifier, expecting end of code. That is the exact same error that we got on the very first one. In fact, all of the errors are unexpected identifier, expecting end of code. And it's only happening on the ones that we feed in using a string. Right? Okay. Is it because string stream SS hasn't been parsed yet? Okay, now I'm getting a segmentation fault, and that may be because I'm trying to print out the result. So this may have just been that simple. And everything's passing. Okay, so what was the error? The error was a memory safety thing. Specifically, you know what? I'm going to SS this arrow code. I'm going to write it this way. Okay, so what was happening is when we call scanner, we're either giving it a string stream, or we're giving it or this is a string stream, right? So we're giving it one or the other. And the problem is we're just, in this case, we're making unique a Tang scanner, so it's a pointer. And then we use that pointer to pass into parser. And then down here, we actually parse the contents of the string stream. Well, what was happening is the string stream variable was created on this line. And when I got to the end of that code block, it was going out of scope. And so when we were trying to read it, called parse, it was no longer valid. Yeah, that's what was happening. Okay, so what is our diff? That's fine, I don't mind setting a default. So, or setting the default like on this there, null opt for iStream code, or code being empty. All right. What do we say here? parser is not loose scope before being parsed. Sure. Okay. And now we have passing tests. That's what we want. Okay, so now on the right hand side, I'm just no, these are all my commits. I don't think I have any of the watch. Nope, I don't. All right, so if we say make all -J8. No, yeah, I can do that. And then say double ampersand build apps tang and feed in fib.tang. And I get that. Okay. And now if I put this as watch-in1 uh-oh. There. Tang. There we go. So every 1 second, it will try to rerun the compile and running our program. But I don't want it to do well, okay. I'm arguing with myself and I'm not even telling you what I'm arguing about. What we want is we want to have some command line options. And so we're going to edit the source tang.cpp. We don't have any command line options. Like I said, we're going to add them. And I think that we can do a couple things here. First of all, we probably just need a void print help. And it's not going to do anything else yet, but we'll do that. And, well, you know what? We will say if, no, I need an argc and argv. Int argc and char star argv. Sure, I'll do it like that. I could do char double star, but this is fine. And what would some of them be? We could say use standard in. Its default will be true. Bool is template, and we will, would that be a true? Yeah. Yeah, we want it to default to being a template. Right now it's defaulting to being a script. That's one of the things we'll fix here. Is template true? We'll leave it at that. Okay, now we've got to go through the command line arguments. And I'm just going to start here. We'll do simple. And we will say for int I is equal to 0, I is less than argc plus I. And why am I doing this? Well, first of all, a lot of people don't know how to parse command line arguments. And there are libraries that can output some nice command line arguments, but this is C++, and you do a lot of stuff yourself here. So let's talk about how we would do this. I'm going to say if. Now we can use string compare. Let's just do C++ reference strcmp string compare, and it takes two const chars. This will do up to a number. You know what? This should be fine. Stir compare. And it's in C string, so I'm probably going to have to pound include C string. Whoops. Well, I'll just do that in a moment. So if stir comp, and this returns a negative number if it's less than, and a 0 if it's equal. And a 1 or greater than 0 if it's greater than. So we're gonna flip that. So if not stir comp, and what are we comparing? argv sub I and help. So if we get that, or not str strcomp argv sub I, and what are we comparing it to? How about -h? That's it. I don't need all of those. I knew it was looking wrong. Help. I'm going to say text. Print help text. Return 0. Print help text. And what would we want for the help text to look like? Let's do cout. I think I want a certain width. So let's do set w and width. What will the width be? I don't know yet. But $30. And I think I'll need an indent, which will also be 30 for the moment. Okay, set the width, and it's going to be -- help, comma, -h. That's kind of our options. An inline. Indent. And now no. Display help message. Okay. And I'm just going to say -- help. All right. What are we missing? Set W is not, because is that in IO manip? Oh, I need a comma. How did I miss the comma? What else? Oh, fine. Maybe unused. Oh, okay. So 30 is definitely way too big. What if I take that down to 15? That could work. Okay, we'll leave it on there. Now, what other things might we want? We might want I think I like the idea of having maybe an evaluate. Or E argument, and it's going to be argument supplied argument. So evaluate the supplied argument instead of standard in. Okay. That's probably fine. What else? So right now it should default to a template, and we should give an option for script, right? So we will say instead of a template. We might, I mean, you could also like, here, let's just save that and see what we get. Okay. So the width is the width of whatever I'm providing. So when I say that, I think it is what I want. Okay. And instead of 30, let's try that as 20. I think I can live with that. All right, so let's now write some of these checks. You know what? Since now I've got this evaluate, well, first of all, okay, so I've got the help. Let's see if it's evaluate or dash E not 3, E. Let's eval is equal to argv sub I plus 1, and we have to say if argc argv plus 1 is less than argc. Let's do it the other way around. If it is greater than or equal to there are not enough arguments, and return 1. Otherwise, eval is that and plus plus I, not return 0. Okay, we'll just keep on going. And you know, we don't need to use standard in because we can have this char star argv to be a null pointer. Can I do it like that? Let's see. Oh, why did I have argv? No, don't do that. Eval. And we'll say eval, yeah. This should be an I. Set but not used. Well, that's where I set it. And it's easy enough to say if eval see if we get there. Okay, so we can't create a program. Oh, it's a shared pointer. Duh. A shared pointer to a program that is should be null. Wait, Hmm. Going back. Okay. Here's what we're going to say. This will be a pointer. This is going to be the memory address of. That's going to be the memory address of. Will it allow me to do that? No, if it's an R value, that's why. Huh. I'm basically trying to get out of having to type program execute out. So, fine, I'm not going to. Not the most elegant, but this will work. Okay, oh, and this should not be CN anymore. It should be eval. See if that still compiles. Still does. All right, and now we want to keep everything in alphabetical order. There. So we've got the eval. If we don't have the right number of arguments, it will error and return an error code. And we just need script. That's the only other one. I'm seeing another problem. Script or S. Then we would say how about is script? All right. So what I'm thinking is this should not be as template anymore. It should be a script because I'm refactoring this as I write it. If is script. This is going to be ugly. Else. No, didn't mean to do that. Template. If it is a script, compile template. Okay. So let's go up here. first of all, you provided, what did I call this up here? Oh. This is going to be rather than a template. Okay? Again, this is ugly. I know it is. We're just getting it to compile. Now, if I run /build apps tang by itself, it waits for impact, or waits for input. And if I say Control D, well, it output A. Why? Because by default it is foo-bar-baz. It's reading it as a template. However, if I say -s and I say foo-bar-baz, oh no, it's also as a, oh, because I wrote this wrong. You're supposed to help me catch these stupid mistakes. True. There. And it exited without any errors. But that's what we're about to make sure that we propagate errors. So, and maybe a separate commit just so we can do this. But if I say this again and say a is equal to 1, print a, it prints a 1. All right. If I say build apps tang and feed in fib.tang, it thinks it's a template. If I say, oh wait, -s, it computes the answer. All right. If I say build apps tang, an expression hello world, it should output hello world because it sees it as a template. And if I say print hello world, it should be just fine. But if I say that and then I say -s, it's a script, it should have printed hello world. Do I need a semicolon? No. Oh, wait. Oh. I'm not printing out my errors. There. Not going to do the -s first. There. So I have to, because I'm doing it in the command line, I have to escape the double quote, but as you see, we get it without the double quote. So, okay. So now if I do it with a -s, it prints hello world, and now, in fact, I think I can, yeah. And I can even say something like 3 plus 5, and it should, no, it doesn't print that unless I say print. Eight. Okay. All right. Let's go ahead and get a commit out of this. Ooh. Where was that? Oh, that's where it was. Okay, now we don't have any extra white space. And what's our message? We're going to say add command line flags to command line utility. How about just add flags? And help text. All right. Now, what else? We want to say if there's an error, we should print that out and return a non-zero code. Okay, so vim source tang. This is going to be ugly at first. Okay, so we're going to say we're going to evaluate a script. If context.result I don't think this is right all the way. But we're going to say 3 plus 5 and there. And it, okay, so it printed out null because that was the thing. So I think we need to say if type ID of that is equal to the type ID of computed expression error, then C error, return 1. Here, return 2. Otherwise, just keep going. Okay, and it just printed out an 8. However, if I run it with a 3 plus, didn't do anything. Let's just see what this is. Oh wait, we're getting an error, don't know how to... Did I just not hit save? No, it's why is it not... There. Figure out what type we're referring to. Oh, it's a garbage collected value. That's why. Yeah, and... Is that right? No. How did we get the... I don't remember. Let's look this up. Bash get previous exit code. Surprise, it's... Oh well. $? Question mark. Okay, fine. $ question mark. Yeah. It... Okay, so that printed out to C error. Okay. Now I'm just thinking of what's an elegant way, because I could just copy and... Wrong window. I could just copy and paste this, 4 times. It's just the difficulty is that program is created in 4 different ways. And I don't really have a way of... You know what? I can do it this way. Shared pointer program Okay. And I should be able to do program is equal to make shared program getting that. And I'm just going to see where my compile problem happens. On line 55. So everything worked after that, or before that. So in this case, there. Okay, this should be compile script cin, and this should be compile template cin. Everything should compile. Once I do all the right stuff. Now everything should compile. Okay, and I'm getting the right error, the correct error. And now I'm going to say eval is script now. I think I can pare that down even more. Colon before semicolon. Oh, yeah. Well. This is just trying to get it all, you know, to compile. There. So it doesn't know how to add these values, but if I say 3 plus 5 and $? 0 because there were no problems. Print 3 plus 5. It prints out an 8, and there was no problem. Okay, and then 3 plus don't know how to add these values. Okay, so it propagates up. I didn't remember if I'd written that. But what does this give us now? A couple things. First of all, we now have a very, very compact you know what? I don't need the make shared. This should all still compile. Oh, except for the it's no longer a pointer. Don't know how to add, but if we say 3 plus 5, 8, no error. Okay. So, where does this put us? Well, also, if we run it as Tang, run it as a script, there we go. Echo $? Still okay, yeah. So this is kind of how we're, you know, here. We will say compile the program, execute the, how about code, rather than code into a program, execute the program. All right, well, I'm back, and I lost power at my house, and everything shut down quite unexpectedly. Thankfully, one of the things I picked up on is when recording, what do I record as in OBS, and there was, and I'd have to look it up, I guess. I could probably find my settings. Is it going to be output? Maybe it's the MKV. But the most important part of this is that there are some video files that if you lose power, like what just happened to me, you lose the entire video. This is not, I haven't even opened, here. open it anyway. There we go. And so I evidently lost some stuff. The last thing was, you can see, you saw this just a moment ago, but I had not hit save yet, so I lost it. The code into a program, and then down here execute the program. And I was just about to hit save and it died. So if I hit play here, I was looking around and it died. Yep. So, yeah, that's what happens. On the right hand side, I'm going to go ahead and rebuild everything. On the left hand side, because now I've removed that file, get status, get diff. Yeah, we collapsed our code down so that it's definitely easier to see, and we are reporting error messages. So the other thing I want to check on is, while I'm here, the include for tang.hpp, because the standalone, we did it. And so now we got to, oh wait, the library macros, we also took care of that. The library extension, I know it sounds like we have, but we don't really have a thing that makes, well, we kind of do, but we're going to think about it some more. I don't have the math library fleshed out. We don't have the date or time library. We don't have a way of, like, if something's going too long, of killing it, so we'll worry about that later. Let's see. Optimizations, that's also coming up, and then tail call optimizations. So, but that puts us in a pretty good place. Git add source tang. We're going to say commit update global to do removing completed features or tasks. I did it on the wrong one. Yeah. I haven't done an amend very often, so yeah, what do we say here? What did we do? We add error message reporting to Tang CLI. How about that? Write that, and there we go. Now, this one is update the global to do. That's fine. Okay. So which one are we going to do next? Not sure. Not sure. But for now, we're in a good place. We should probably make docs PDF in case it does need to update anything. I don't know what it would update. Didn't have to do a lot. Didn't have to do very much. So for episode, what are we? Is it 80? Episode 80. Well, with the excitement of me losing power, and it was less than a second. It was just everything went down and everything came. Yeah. I don't remember the episode numbers anyway, but after all that and my frantic search for did this save? Really glad I'm using that format. That saves all along. Anyway, okay. So update the docs. Push everything up. Git tag episode 80. Episode 80. Episode 80. There we go. And our lines of code, 10,666 lines and 3,500 lines of comments. We don't have a lot of comments in that command line thing. Are there other things we could do? Maybe. Well, once we add the kind of timeout limiting thing, we can do that. I'm really wanting to do an optimization around strings, and we'll worry about that later. Oh well. Okay. Now I'm gonna just wrap it up and try to get all this spliced back together. Thank you again for joining me, and well, hope it's entertaining, useful, whatever. Thanks. Bye.